In last lecture we have seen which can be binary tree or complete binary tree. And suppose we have this tree, then this is the level 1, this is level 2, this is level 3, this is level 4, and this is level 5. So we can say the depth of or height of complete binary tree or binary tree, it is like 1, 2, 3 and 4. So depth or height of binary tree or complete binary tree is equal to 4. 1, 2, 3, 4. So level is 5, so depth of height is 4. So here the number of nodes is 2 to the power 4 minus 1, the number of nodes 2 to the power 4 minus 1, and here number of nodes are 2 to the power 5 minus 1, like that. 4 minus 1 to the power 4 minus 1. So we can say simply a node which contain at least one child called internal node, or we can say if complete binary tree contain n leaf node, then it should have n minus 1 internal node. So total 2n minus 1 nodes. So we can say these are odd nodes, odd numbers, and if even number of nodes, then we can say total 2n, like that. So we can say total number of nodes at a k level in complete binary tree will be equal to 2 to the power k minus 1. From here we can see that at 4 level 2 to the power 4 minus 1, 5th level 2 to the power 5 minus 1. So at k level 2 to the power k minus 1 in general. If n number of nodes are there, total n. So n is equal to 2 to the power k minus 1. Total number of nodes we are supposing n. So at level this. So we can say simply n plus 1 is equal to 2 to the power k. So we can say log base 2 n plus 1 is equal to k. Equal to k. So if fifth level, so you can say 31 plus 1 is equal to log 2 32, that is equals to fifth level. Or depth, we can say depth is 5, so like that, it will be like that. Or we can say number of level minus 1 is equal to height of complete binary tree. Number of levels minus 1, number of levels minus 1, here number of levels are 5. So number of levels minus 1 is equal to height of complete binary tree, height, or we can say depth. So we can say height of complete binary tree is equal to number of level minus 1, or we can say log n plus 1 number of levels, n plus 1 base 2 minus 1. So this is for complete binary tree, or we can say height of binary tree is equal to n minus 1 in the case of maximum number of nodes are available, or minimum in the case of minimum it will be log n plus 1 base 2 minus 1. So this is how we can calculate the number of levels or how many number of nodes are available in complete binary tree or binary tree. So in next lecture we will learn how we can represent trees in the computer.